If someone forced you to be teleported at random into ancient Earth, you would probably beg to be dropped on land and not in the water. Because through most of history, the oceans have been where the truly unfair things live. At almost every point in geologic time, there's some nightmare in the sea that makes the land predators look almost reasonable. There was even a famous documentary that tried to rank the deadliest prehistoric seas of all time. It went through Jurassic oceans full of Plesiosaurs, Paleozoic waters patrolled by sea scorpions and giant cephalopods, and even the Cenozoic age that gave us the largest shark ever. But in the end, the winner, the worst place you could possibly go swimming, wasn't any of those. It was a shallow tropical sea that once sliced North America in half. Today we call it the Western Interior Seaway. Some people give it a much more accurate nickname, Hell's Aquarium. If you live in the United States, Canada, or Mexico, there's a decent chance you've stood on top of what used to be this ancient sea without even realizing it. During the Late Cretaceous, this body of water didn't just form a coastline, it effectively split the continent into two long island continents. To the west was Laramidia, a narrow strip of land crammed with famous dinosaurs. To the east was Appalachia, another landmass with its own unique ecosystem. Between them lay a long, warm, shallow sea, stretching from the Arctic down toward what is now the Gulf of Mexico. The Western Interior Seaway first took shape in the early Cretaceous, roughly 100 million years ago. It persisted in one form or another until about 66 million years ago, into the very earliest Paleocene. So for around 34 million years, a huge swath of North America was underwater. The seaway was at its most extreme and terrifying during the Campanian stage of the Late Cretaceous. This interval ran from about 83.6 to 72.1 million years ago. At that time, the Western Interior Seaway was a warm, tropical epicontinental sea. At its widest, it spanned roughly 600 miles, or about 970 kilometers. Its length stretched for more than 2,000 miles, around 3,200 kilometers, from north to south. Despite its size, it was surprisingly shallow for an ocean-scale body of water. Average depths may have hovered around 50 meters, about 150 feet. Only in the deepest central trough might it have reached around 900 meters, or roughly 3,000 feet. This shallow, sunlit, nutrient-filled basin was the perfect stage for an insane amount of life. Unfortunately, a disturbing percentage of that life was designed to eat other life. If you could hover above this ancient sea, you wouldn't see one main monster. You'd see a food web stacked with predators on predators on predators. The undisputed celebrities of this ecosystem were the Mosasaurs. These were not dinosaurs, and they were not marine crocodiles. They were giant marine lizards, more closely related to monitor lizards and snakes. Imagine a Komodo dragon stretched out, streamlined, remodeled into a high-speed torpedo with 4 flippers and a powerful tail. That gives you the basic vibe of a mosasaur. Early species swam with sinuous eel-like motions of the body. Later, more derived mosasaurs evolved tail flukes and more shark-like propulsion. They were muscular, flexible, fast, and very good at turning meat into not meat. Nowhere on Earth did mosasaurs diversify more than in the Western Interior Seaway. Over a dozen genera are thought to have lived here at the same time. They range from small forms around 2 meters long to giants pushing 18 meters, around 59 feet. In theory, you might hope that only a few of them would actually see you as food. In practice, several of the commonest species were more than capable of turning a human-sized animal into a snack. One of the most abundant mosasaurs here was Clidastes. It was the smallest of the big 3, but still far from harmless. Large individuals could reach about 6.2 meters in length, roughly 20 feet. That's comparable to the length of a big great white shark, even if Clidastes was slimmer and lighter. Its narrow, flexible body made it highly agile, especially in relatively shallow coastal waters. Its teeth were smooth and sharp, ideal for gripping slippery prey. It likely hunted schooling fish, smaller marine reptiles, and soft-bodied animals like squid. There's also evidence that some mosasaurs, including Clidastes, could tolerate brackish or even fresh water for a time. That means this predator may have moved up estuaries and into rivers, making it even harder to avoid. If you wanted a shallow lagoon to feel safe, Clidastes would personally ruin that. Another common mid-sized mosasaur was Platecarpus. This species was a little larger and more robust than Clidastes. Adults may have reached around 7 meters, or 24 feet, from snout to tail. Their mass could approach a ton, similar to a large Nile crocodile. That alone should be enough to raise your heart rate. Yet Platecarpus doesn't seem to have been a specialized giant hunter. Its teeth are relatively delicate and prone to breakage. This fragility suggests that it targeted softer prey, fish, squid, and other animals with minimal armor. It likely favored somewhat deeper waters, away from the very shallow shore. So while Platecarpus would absolutely be a danger to a human-sized swimmer, it was more of a terror to the mid-level residents of the water column. If you really wanted to guarantee a horrible time, though, you had to meet Tylosaurus. Tylosaurus was one of the top apex predators of the Western Interior Seaway. Adults regularly reached lengths of 12 to 15.8 meters, or about 39 to 52 feet. That puts them in the same length range as humpback whales. Its skull was large and packed with thick, recurved, finely serrated teeth. A mature Tylosaurus could have up to 32 functional teeth at once. These were not delicate fish snatchers. They were heavy-duty tools built to tear large prey into pieces. Fossil stomach contents show that Tylosaurus ate plesiosaurs, turtles, bony fish, sharks, diving birds, and other mosasaurs. If it lived in the water and wasn't enormous, Tylosaurus probably tried to eat it at some point. Even if it was enormous, Tylosaurus might still have given it a go. The most distinctive feature of Tylosaurus was its snout. Teeth were set further back than in many other mosasaurs, leaving the very tip as a solid bony ram. The end of the snout bore a reinforced knob of bone, backed by structures that helped absorb shock. This has led paleontologists to propose that Tylosaurus used its snout as a battering ram. It may have slammed prey animals at high speed to stun, injure, or even kill them. Scars and damage on other marine reptiles are consistent with violent ramming impacts. There's even a specimen of another large mosasaur whose brain case appears to have been smashed open, likely by a Tylosaurus headbutt delivered at the worst possible time. That's not just predation. That's a torpedo with anger issues. And Tylosaurus was not the only giant mosasaur cruising these waters. Another heavyweight was Mosasaurus itself, the genus that lends its name to the entire group. In the Western Interior Seaway, Mosasaurus may have occasionally reached about 17.1 meters in length, or 56 feet. Estimates suggest large individuals could weigh over 10 tons. Unlike Tylosaurus, Mosasaurus didn't have a specialized ram snout. It instead leaned into raw biting power and cutting ability. Its skull was proportionally large for its body, allowing room for massive jaw muscles. The teeth of Mosasaurus had sharp tips and two opposing cutting edges. Fine structural features in the enamel helped each bite grip deeper and resist breakage. Biomechanical estimates suggest a bite force somewhere in the range of 13,000 to 16,000 pounds per square inch. That's roughly 4 times the bite force of a modern saltwater crocodile. Put simply, if Mosasaurus got a good hold on you, you weren't leaving with all your parts attached. Like Tylosaurus, it had a varied diet. It likely hunted other marine reptiles, large fish, turtles, and anything else its jaws could close around. Rather than relying heavily on smell like many sharks, Mosasaurs seem to have leaned more on eyesight in open water. Their orbits and skull structure suggest strong binocular vision and good depth perception. In the murky waters of the Seaway, that would have been a huge advantage. And as if Tylosaurus and Mosasaurus weren't enough, the Seaway also hosted large species of Prognathodon. These mosasaurs were only about 3/4 the size of Mosasaurus, but still massive and heavily built, with a reputation for powerful jaws. So on the mosasaur side alone, Hell's Aquarium already lives up to its name. But the worst bite in these waters may not have belonged to a mosasaur at all. Lurking closer to the shores and estuaries was one of the largest crocodilians to ever exist. This was Deinosuchus. Its name translates to terrible crocodile, which is modest. Deinosuchus inhabited the coastal margins of the Western Interior Seaway and nearby river systems. It lived on both the eastern and western sides of the Seaway. On the eastern side, individuals were more numerous but generally smaller. On the western side, the population seems to have been rarer but significantly larger. Some western Deinosuchus may have reached lengths of about 12 meters, or 39 feet. That's longer than most buses. They were also extremely robust. Body mass estimates for the largest specimens approach 8.5 tons. Unlike many of the sleek marine reptiles, Deinosuchus came with heavy armor. Its back was covered in large, thick osteoderms, bony plates embedded in the skin. These scutes were so big and heavy that early paleontologists mistook them for the armor of an ankylosaur dinosaur. The osteoderms didn't just provide protection, they also served as attachment points for powerful muscles, helping support the animal's bulk on land. All of that armor and muscle framed an enormous skull. The snout shape was broadly alligator-like, wide and deep. Inside that skull were exceptionally strong jaw muscles. Biomechanical reconstructions suggest that Deinosuchus had a bite force possibly exceeding 100,000 newtons. To put that in perspective, that's stronger than most estimates for T-Rex and several times the force needed to crush a car roof. Its teeth were large and conical, but with a twist. Towards the front of the jaws, the teeth were sharper and more pointed, useful for gripping. Farther back, they became blunter and more robust, acting as crushing tools. This combination suggests that Deinosuchus specialized in smashing through hard things. Fossils show bite marks on turtle shells and dinosaur bones that match its dentition. Its diet likely included marine turtles, large fish, and unwary dinosaurs that wandered too close to the water's edge. If you were a hadrosaur trying to drink in a coastal swamp, Deinosuchus turned that into a boss fight. While the coasts and reefs were patrolled by crocodilian supertanks, the open waters had their own resident horrors that didn't have skeletons like reptiles at all. Some of the most unsettling were giant cephalopods. This sea wasn't just home to little squids hiding from everything. It hosted some of the largest soft-bodied cephalopods known from the Cretaceous. Among them were forms like Tusoteuthis and Xiphactinus, members of an extinct group of squid-like coleoids. These animals probably looked like chunky, thick-bodied squids with relatively short mantles and muscular arms. In life, they were more closely related to modern octopuses and squids than to ammonites. When they first hatched, they were tiny and extremely vulnerable. Evidence suggests that juvenile cephalopods were a major food source for many marine predators. Fossil stomach contents from fish and reptiles often contain the remains of young cephalopods. Being everyone's appetizer is not a sustainable life strategy. In response, these Cretaceous coleoids appear to have grown very quickly. They also showed extreme variation in size between individuals of the same species. Some adults were only as long as a human arm. Others could reach lengths of around 3 meters, or 10 feet. At that size, they flipped the script. Instead of being eaten, they became active predators themselves. Armed with 10 tentacles lined with suckers, they could wrap around fish, invertebrates, and even small marine reptiles. Powerful beaks at the center of the arms would then slice prey apart. Like modern squids, they probably used jet propulsion to maneuver, expelling water through a siphon to dart forward or backward. Many researchers think they could also release clouds of ink to escape larger predators. The one thing they lacked was armor. Their bodies were almost entirely soft tissue. In a sea full of mosasaurs and sharks, that's a problem. So nature tried a different approach with another cephalopod, one that brought its own armored home. That armored cephalopod was Parapuzosia. Unlike the coleoids, Parapuzosia was an ammonite. Ammonites were shelled cephalopods related to modern squids and octopuses, but with external spiral shells. The shell of Parapuzosia was made of calcium carbonate. It formed a tight spiral with internal chambers that the animal could fill with gas or fluid to control its buoyancy. When scientists examine these shells, they find intricate arrangements of crystals and prisms in the different layers. These structures made the shell strong despite its size. And size is where Parapuzosia truly became ridiculous. It is the largest known ammonite and, as far as we can tell, the heaviest cephalopod and heaviest invertebrate of all time. The biggest shells attributed to Parapuzosia may have reached diameters of around 3.5 meters, or roughly 11 feet. With the animal's soft body included, total mass could easily exceed 1.5 tons. Nearly half of that would have been shell. If you could somehow pull the animal out of its spiral shell and stretch it straight, its body could have been on the order of 18 meters long, around 60 feet. That's about twice the length of a whale shark. We don't know exactly how Parapuzosia lived day to day. All of its closest relatives are extinct, and there's no modern animal that fills quite the same niche. However, the structure of its shell and the geology around its fossils provide clues. It seems to have favored the upper layers of the water column. It probably didn't descend much below about 250 meters, or 800 feet. Fossils of Parapuzosia are widespread throughout deposits of the Western Interior Seaway. That suggests that these giants were not rare, deep-sea phantoms. They were common enough to be a normal part of the ecosystem. Some researchers propose that large Parapuzosia individuals were active predators, catching fish and other cephalopods with their tentacles. Others argue that they might have been slow-moving, feeding on drifting organic matter or slow prey near the sea floor. Either way, the idea of a 1.5-ton shell beast drifting through the same waters as giant mosasaurs and crocodilians tells you everything you need to know about Hell's Aquarium. As if all that weren't enough, the Western Interior Seaway was also shark country. Sharks weren't the top rulers here, but they were everywhere. They filled roles as scavengers, mid-level predators, and occasionally serious competition for the reptiles. Some of them reached extreme sizes for their kind. The largest shark in these waters was not a classic meat slicer, but a shell crusher. This was Ptychodus. Imagine a shark roughly comparable in size to a whale shark, but built for a very different diet. Instead of filter-feeding plankton, Ptychodus specialized in hard-shelled prey. You can see this just by looking at its teeth. Rather than sharp, triangular blades, Ptychodus had broad, flat tooth plates. Hundreds of these teeth formed pavement-like crushing surfaces in the jaws. Some individual teeth are longer than a standard ruler. These dental anvils were perfect for smashing through shells and exoskeletons. Ptychodus likely focused on large shellfish, crustaceans, and possibly marine turtles. To a human-sized animal, it might not have been the worst shark in the world. To anything with a shell, it was basically a swimming hydraulic press. If you wanted a more classic predatory shark though, the Ginsu Shark had you covered. Its scientific name is Cretoxyrhina mantelli. This was a large lamniform shark, part of the same broader group that includes great whites and makos. Despite not being closely related to modern great whites, it looked and behaved remarkably similarly. This is a textbook example of convergent evolution. Adult Cretoxyrhina could reach lengths of around 8 meters, about 26 feet. They may have weighed over 5 tons. So we're talking about a shark roughly the size of a bus, optimized for speed and power. Its skin was covered in placoid scales arranged in patterns that help reduce drag. The shape and structure of these scales are similar to those found in the fastest modern sharks. Its tail fin was a high-performance design associated with sustained high-speed swimming. Modeling suggests that Cretoxyrhina could reach speeds of around 70 kilometers per hour, about 43 miles per hour. At those speeds, the difference between a near miss and a catastrophic hit is measured in fractions of a second. The jaws of Cretoxyrhina housed rows of large, blade-like teeth. Each tooth was bigger than those of most modern great whites. They also sported a thick coat of enamel to withstand the enormous stresses of high-speed collisions and bone-crunching bites. Fossil evidence tells us what this shark used all that hardware for. Many of the bite marks attributed to Cretoxyrhina are found on other predators. Its diet included other sharks, mosasaurs, plesiosaurs, and large bony fish. It frequently went after other apex predators. This was a shark that hunted the hunters. Occasionally, it even scavenged dinosaurs. Bones of ankylosaurs and hadrosaurs with Cretoxyrhina-like bite marks suggest that their carcasses sometimes washed out into the seaway and were torn apart by these sharks. So even on the edges of Hell's Aquarium, sharks were recycling dead dinosaurs for calories. A bit closer to shore, another lamniform shark was causing problems on a smaller scale. This one is known as Squalicorax, or more memorably, the crow shark. It was a mid-sized predator, usually between about 1.8 and 4.8 meters in length, roughly 6 to 16 feet. That's about the size range of a modern tiger shark. The resemblance doesn't stop at length. The teeth of Squalicorax are also similar to tiger shark teeth. They are numerous, moderately sized, curved, and finely serrated. They're perfect for sawing through flesh and tough tissue. With that dental toolkit, the crow shark could tackle a variety of prey. It likely fed on fish, small marine reptiles, and carrion. There's strong evidence that Squalicorax was an enthusiastic scavenger. Dinosaur bones with distinctive crow shark bite marks show that it fed on terrestrial animals when their bodies ended up in the sea. Unlike Cretoxyrhina, Squalicorax seems to have favored more coastal waters. It also developed a very specific and terrifying niche. It sometimes attacked pterosaurs. More than one pteranodon fossil bears tooth marks from Squalicorax. This implies that the crow shark was adept at spotting pterosaurs when they were low over the water, likely when they swooped down to catch fish. With excellent vision and quick acceleration, it could launch upward to grab them at the surface, so even the rulers of the sky were on the menu in this ocean. Among the bony fish of the Western Interior Seaway, one species has become notorious. Its name is Xiphactinus. Some people just call it the X-fish. It was a member of an extinct group of ray-finned fishes known as ichthyodectiforms. These fish were fast, powerful, and not very pretty. Xiphactinus might be the ugliest of the lot. Its body was long and muscular, but its most striking feature was its head. The snout was broad, blunt, and pushed back, giving it a squashed, menacing profile. The jaws were large and lined with sharp teeth. The entire skull looks like it was purpose-built to grab and swallow anything unfortunate enough to fit inside. Adults could grow to be about 5 to 6 meters long, around 16 to 20 feet. At the lower end of that range, a Xiphactinus would have no trouble swallowing a human-sized animal in one gulp. We know it could do this because we found the proof. One famous fish within a fish fossil preserves a medium-sized Xiphactinus that died with a 1.9-meter-long fish inside its body. The prey fish is almost intact, showing that it was swallowed whole shortly before the predator died. More than a dozen similar specimens show large fish stuffed inside the stomach area of Xiphactinus. This fish could also use its teeth to cut and tear when needed, allowing it to scavenge larger carcasses. So in the Western Interior Seaway, even the bony fish were capable of jump-scare-level horror. With all of these monsters, it might be easy to forget that the Seaway also hosted one of the most iconic marine reptile groups of all time. These were the Plesiosaurs. Plesiosaurs had 4 large flippers instead of limbs. Their bodies were broad and flattened. They had relatively short tails compared to Mosasaurs. Some species had moderate necks, but others had absurdly long ones. The long-necked forms, called Elasmosaurids, reached the most extreme proportions. To swim, Plesiosaurs flapped their 4 flippers in a motion that has been compared to underwater flying. They tended to prefer shallower waters, such as continental shelves and coastal zones. Multiple plesiosaur species lived in the Western Interior Seaway. Most belonged to the classic plesiosaur and elasmosaur lineages. A few polycotylids, shorter-necked, more streamlined forms, were also present. Many species reached lengths over 5 meters, or about 15 feet. The longest were giants such as Elasmosaurus and Albertonectes. Both of these elasmosaurids may have grown to about 11.6 meters, roughly 38 feet, from head to tail. Their necks contained an incredible number of vertebrae. Elasmosaurus in particular holds the record for the most neck vertebrae of any known animal. Despite their length and eerie silhouette, these long-necked plesiosaurs were not designed to tackle huge prey. Their heads were relatively small, and their jaws were narrow. This anatomy suggests that they specialized in small, quick animals. One common idea is that they used their necks like stealth periscopes. By keeping their heavy bodies farther away and snaking only the head and neck forward, they might have approached fish without alarming them. To an unwary fish, the head might have looked like just another medium-sized animal, not the tip of a 10-meter predator. Once in range, the plesiosaur would snap its jaws shut. Their interlocking teeth were angled so that when the mouth closed, they formed a kind of natural cage. This fish trap dentition made it very difficult for slippery prey to wriggle back out. In addition to fish, elasmosaurids likely fed on small invertebrates like snails and clams. They were not the apex predators here, but they were extremely good at what they did. Their diversity and abundance show that this strategy worked very well, at least until the end. By now, Hell's Aquarium sounds like a monster crossover movie. Giant shell-crushing sharks, high-speed Ginsu sharks hunting other apex predators, crocodiles with a bite stronger than T-Rex, mosasaurs with built-in battering rams, and 16,000 psi bites. Kraken-sized cephalopods and ammonites as heavy as small cars, ugly fish that swallow other fish nearly their own size in a single gulp, and elegant, long-necked reptiles sniping fish at a distance. The obvious question is, what happened to all of them? The Western Interior Seaway did not disappear overnight. Over millions of years, tectonic changes gradually reshaped the continent. Uplift of the interior and falling global sea levels caused the seaway to grow shallower and narrower. Coastlines retreated, habitats shifted, and some lineages declined slowly as their preferred environments vanished. But the real finishing move came from space. About 66 million years ago, a large asteroid slammed into what is now the Yucatan Peninsula. This impact is famously associated with the mass extinction that ended the age of non-avian dinosaurs. Its effects were especially brutal for shallow seas near the impact site. The Western Interior Seaway was one of those seas. The collision launched enormous tsunamis that ripped through the basin. It threw vaporized rock and dust into the atmosphere. The chemistry of the oceans changed as acid rain and debris fell back to Earth. In some fossil deposits from around the time of impact, fish skeletons have tiny spheres and traces of iridium lodged in their gills. Iridium is rare in Earth's crust, but more common in meteorites. Finding it in the gills of fish is like catching the disaster mid-breath. Many of the most iconic Western Interior Seaway predators did not survive this transition. Mosasaurs vanished entirely. Plesiosaurs disappeared. Large ammonites like Parapuzosia were wiped out. Major shark lineages and big bony fish were heavily pruned. The seaway itself dwindled, broke up, and eventually vanished as an ocean-scale feature. What remained were rivers, lakes, and smaller marine basins that would later host their own sets of strange animals. The ocean after Hell's Aquarium was not suddenly safe. New monsters evolved in the millions of years that followed. At one point in North America's seas, there was even a dolphin-like mammal with spear-like teeth that would have looked more like a weaponized javelin than a friendly bottlenose. But none of those later ecosystems combined quite the same mix of shallow warmth, continental confinement, and predator overload as the Western Interior Seaway. So the next time you feel uneasy looking down into deep blue water, remember that it could be worse. You could be standing on the shoreline of Cretaceous North America, staring out over a warm, shallow sea where nearly everything with teeth is overbuilt, oversized, and constantly hungry. And that sea really did exist. We just gave it a friendly name later, the Western Interior Seaway, Hell's Aquarium.